Okay, today we're going to talk about extrema, or extreme values. There's a few definitions we need to start with. Okay, so let's write this one down. F of C is the absolute minimum of F if F of C is less than or equal to F of X for all X. Okay, and F of C is the absolute maximum of F if F of C is equal to or greater than F of X for all X. Okay, visually, the absolute minimum is the lowest point on the graph of F, and the absolute maximum is the highest point on the graph of F. There might not be any. Let's point that out. This is really important. Okay, I'm going to show you a couple of pictures here. Okay, look at these two graphs here. Okay. In the top picture, labeled A, I want to point out that that has an absolute maximum. I can't tell exactly what it is. It looks to me like it's about 5, but let's not guess. Okay, the point is, though, that I can say for sure it has an absolute maximum at x equals 0. Okay? That's the absolute maximum. This graph does not have any absolute minimum. It's tempting to say, well, isn't this right here the absolute minimum, and another one there? But those points aren't on the graph, are they? And then some people are even tempted to say, well, then the point right before that, just before you get to the open point, would be the minimum. But the thing is, that doesn't exist, does it? There's no such thing as the point just before the open hole. No matter how close you get to that hole, I can always get closer, which means that my point would be lower than yours, which means yours was not the absolute minimum. Okay? Now look at the second one, marked B. That one does not have an absolute maximum. These points here coming along here are getting higher and higher, but no matter how close I get to that missing point there, my points can always get closer, which means that they would always get higher. They're bounded. This graph is bounded above. It can't get any bigger than 1. But no matter how high you are on that graph, you can always get higher. So there's no absolute maximum. But there is an absolute minimum, which I'm not sure what it is again, but it looks like it's probably 1. But even though I'm not sure what the maximum value is, I can tell that the maximum value occurs at x equals 2 and also at x equals -2. Okay? So, not every function will have an absolute maximum or an absolute minimum. Okay? But there is something called the extreme value theorem. Let's write it down. And it says if f is continuous on a closed interval then f will have an absolute maximum and an absolute minimum on that interval. Okay, so those two pictures off on the left, are those contradicting the extreme value theorem? Well, the answer is no, they're not contradicting the extreme value theorem, because the extreme value theorem only holds if f is continuous and you're looking on a closed interval. So the top one, notice that the interval here is not closed. That's why the function is able to get away without having an absolute minimum. And in the second picture, the function's not continuous because you have a removable discontinuity right there. Okay, so those two pictures do not contradict the extreme value theorem. The extreme value theorem does not pertain to those two pictures because those two pictures do not show a continuous function on a closed interval. The interval in the second picture is closed, but the function is not continuous. Okay? Okay, new definitions here, and I think I'll actually put these up here. Okay, f of c is a relative minimum, or just so you know, this might come up in the homework program, another term for that is local minimum. Our book uses the term relative. I'm not sure what the homework will use. They're interchangeable. Relative minimum and local minimum mean the same thing. Okay? So is a relative minimum if f of c is less than or equal to f of x for all x in some open interval containing c. I'll draw a picture of that, but before I do, let's write down the same idea for maximum. F of c is a relative or local maximum if f of c is equal to or greater than f of x for all x in some open interval containing c. Okay, let's look at a picture to see what that must be trying to say. Okay, so suppose that f, when you graph it, looks something like this. I want to, let's see, I don't hope this doesn't erase the whole thing. Okay, I want to make this go down further here. And let's put an open circle there. Okay, so let's look at that. So first, can we find the absolute maximum and absolute minimum if they exist? So can we do that? So I would say the absolute maximum is occurring at that point right there. So the absolute maximum value, that's the absolute maximum point on the graph. The absolute maximum value would be whatever this y value is. And that absolute maximum occurs at whatever this x value is. Okay? How about absolute minimum? I would say that there is not one. Okay? Now, look at this point. It's at the top of a hill, right? It's like a maximum, isn't it? But it's not as high as the absolute maximum, so it is not a maximum. But it is the highest point in its area. What do I mean by that exactly? What I mean by that is I can mark off an open interval here. And in that interval, that's the highest point. I could have made that interval smaller, and the same fact still exists. Oops, I didn't want to go that far. I could have marked off an interval like this and say in this area that red point is the highest point. I could have even made it a lot bigger. I could say from here to here. In that area, that red point right here is the highest point. But if I go too far, if I try to take this over to there, then that's no longer the highest point because now this one is. Okay? So the point is, because I can put an interval, an open, that's important, open interval here, and in that area, this point is the highest point, then that is what we call a relative maximum. Well, that point is a relative maximum point on the graph. The relative maximum value is whatever that y value is, and that relative maximum occurs at whatever this x value is. Okay? And likewise, you probably noticed that this point over here is a relative minimum point. Okay? And in this area here, it is the lowest point. Okay? And a very important thing in calculus is to be able to find relative maxima and minima, which is the plural, from an equation. Okay? Now, how are we going to do that? Let's talk about that for a minute. Okay, let me introduce the idea of a critical point. Okay? Or a critical number. Both of those. I'm going to define those both. Okay? So, if C is in the domain of F, and any one of these following things happens. C is an endpoint of the domain, or f prime of c equals 0, or f prime of c doesn't exist. If any of those three happens, then C is called a critical number. Of f. And let's just add on to this. And the point CF of C is a critical point of the graph of f. Now I'll tell you that the book leaves this one out, and it only uses these two for the definition of critical number. That is not the normal way of doing it. Usually this first condition there are also called critical numbers. Okay? And here's what's important. Maxima and minima occur at critical points. Not every critical point will be a maximum or a minimum, but every maxima and minima will be at a critical point. So, if you want to find, let's just say this, the absolute maximum and the absolute minimum of a function, then what you do is pretty simple. You look at the domain. If the domain has any endpoints, then you calculate f at the endpoints. You look at the derivative of f, and anywhere where the derivative is 0 or non-existent, you calculate f at those points. And out of all of those, whatever's the highest is the absolute maximum, and whatever's the lowest is the absolute minimum. Okay? Now, relative maximums and minimums we'll have to worry about separately. Right now, let's just worry about absolute. Okay? So let's do an example here. Find the absolute extrema. That means the absolute maximum and the absolute minimum of this function 2x cubed plus 3x squared minus 12x on the domain from 0 to 3. So I know that function is a polynomial. Normally you would say its domain is all real numbers, but we are given a smaller domain to work on. They don't want us to look at all real numbers. They only want us to look at this closed interval. Okay, so let's make a list of the critical points. Well, the critical numbers, let's say. So automatically 0 and 3 are critical numbers because they are endpoints in the domain. You see, now, if that had said, for instance, that, then I wouldn't list 3 as a critical point because it's not in the domain. It's an endpoint of the domain, but it's not in the domain, you see. Okay, so there's 2 critical numbers. Then I find the others, which are where the derivative is 0 or where the derivative doesn't exist. So let's find the derivative. That would be 6x squared plus 6x minus 12. Okay. Is there anywhere that that derivative is non-existent? The answer is no. That derivative is a polynomial and exists everywhere. Next question. Is there anywhere that that derivative is 0? Well, let's just check and see. Let's write 6x squared plus 6x minus 12 equals 0. Okay, we can divide everything by 6. That'll make it a little easier. And now I notice that I can factor the left-hand side. So the derivative is 0 when x is negative 2 and when x is 1. Now we've been told to only look from 0 to 3, so I will throw out the negative 2. It's not in the range we were told to look at. So we have one more critical number, which is 1. Okay. Now, let's find the values of the function at those numbers. F of 0, because if there is a maximum or minimum, which by the way I know there is because I've been given a closed interval for a domain, and f is a polynomial, so it's continuous, so the extreme value theorem tells me there is going to be an absolute maximum and an absolute minimum. They have to occur somewhere at those places. So let's just see. F of 0 equals, well, I notice that that would be 0. F of 3 would equal 45. And f of 2 would equal 4. So our absolute maximum value is 45, and it occurs when x equals 3. Our absolute minimum value is 0, and it occurs when x equals 0. Okay, so pretty straightforward, not a lot to it. For the relative maxima and minima, if there are any, we're going to find that in the next lecture. Okay.